Okay, let me start. First of all, Mingalapa, everyone, and I'm really happy to join you all in this session. And first of all, I want to thank MMNOG 6 organizing committee for giving me the opportunity to talk during this session. And I hope that you have had a good event so far. So my presentation is going to be on DNS operations. So, I try to give you some understanding of DNS concepts and the operational aspects. I hope you can hear me, and also you can, try to get some useful things out of this presentation. In case if you have questions, you can either ask or put that into the chat window, or we can take some question and answer session during the end of this session, right? Again, really happy to at least, come and do this session virtually. It would have been really great if I could be there on site, which I used to do in the past. But hopefully in the future, I will see you all in Myanmar. Okay, now given that, so let us get started with the contents. So initially, I will try to give some introduction about the DNS. Now, if you see this slide, there are a number of things that you should see. You may have seen that I introduced, when I had my first slide, I put that I'm from ICANN. So there is some reference to ICANN in this slide as well. So ICANN is the Internet Corporation for Assigned Names and Numbers. I believe that you are kind of familiar with ICANN at this point of time. But when it comes to the DNS coordination, ICANN takes a very important role. And so it's good to know about ICANN's involvement here as well. So there are registry operators. Usually we have the ones who manage the top level domains. So there are, when you think of DNS, there are different type of top level domain categories. We have generic top level domains, or what we call GTLDs. And then we also have CCTLDs, country code top level domains. They are like .mm for Myanmar. And then also we have IDN top level domains as well. The new generic top level domains, the ones that was delegated during the last 10 years or so. So there are, different types of top level domains. Now ICANN has got contracts with generic top level domains and the new generic top level domains. ICANN does not have contracts with country code top level domains or CCTLDs, but we have a very close relationship. And say, for example, even in Myanmar, for many, many years, with .mm registry operators, we have been collaborating on several aspects, right? And supporting to run the .mm zone in a stable way, okay? So you can see that there are some contractual relationships here. There is what we call a registry agreement between ICANN and the registry operators, but this is more for generic top-level domains like .com or .net and so on, or the new generic top-level domains. There are many new generic top-level domains. Also, there are, in this whole system, there are also entities called registrars. So registrars, they have some contractual agreements with the registries, as you can see in this slide. Also, there are some registrars who are accredited by ICANN, right? So that is why you will see some registrar accreditation agreement with ICANN. So there are some registrars, I mean, they are called ICANN accredited registrars. So they have some sort of a binding with ICANN. But there are, of course, it doesn't mean that every registrar has to be ICANN accredited registrars. There are registrars who are not ICANN accredited registrars as well, okay? Then depending on the registrar functions, some of them, they also have some entities called resellers, domain name resellers. So they may have some agreements between the registrars and the resellers as well. Okay, and then you'll find the registrant. So these are all different terms that we use in DNS ecosystem, right? So I was talking about registries or the registry operators, registrars, resellers, and then we also have registrants. So if you want to get your own domain, you are a registrant, right? So you can either get it from a reseller, you can get the domain name either from a reseller or from a registrar, all right? So either way, if you get it from whatever the party, you may be having some kind of an agreement with the reseller or with the registrar. That is why you will see some registrant agreement. Basically, you are accepting the terms of service, terms of conditions, how this domain name should be managed, and basically, you know, you are basically agreeing to run it with some certain guidelines so that it helps the DNS ecosystem to function correctly, right? So this is what we call the relationships between different parties, and overall, you can consider it as a DNS ecosystem. It is not just one party who run the DNS. There are many parties involved. Now, in this slide, I'm only showing you the high-level overview of administrative parties, right? The registries, registrars, resellers, registrants, and then, of course, ICANN. But then there are other side of this whole thing as well, which is the technical operations, right? So before I really go into more of the technical operations, I want to give some idea about the administration as well, because it is, as an operator, if you're going to manage DNS, it is important to know these administrative functions as well, especially because nowadays there are lots of abuses happen in DNS. There are lots of DNS abuse related matters that you may want to take it up with these registrars, registries, and so on, or you may have to come to ICANN as well if it is related to some compliance matters related to the these domains, right? So it's good to have some idea of these administrative relationships, especially considering that DNS is a kind of, you know, ecosystem where there are several parties operate in this space. Okay. Yeah, so let's now move on to next slide. Now, when you think of DNS, it is a hierarchical database. All right. Now, I have used a term database, but in DNS terms, we call it as a zone, right? So zone is actually a database. We also call this, there are some documentation. You may also see the term domain, right? Now, when you think of the name or the terminology called domain, domain means you are given a certain namespace, right? It is a namespace, or you can still call it as a database, right? So once you are given this database or a domain, you are supposed to manage that namespace, or you are supposed to manage that domain. But DNS is hierarchical in such a way that this namespace can be further delegated, right? So I used a new term here called delegation. So delegation means you are giving part of your responsibility to another party, right? So which means if you have given a certain namespace, certain database space, you can give part of it to another party, right? So this is what we call a delegation. So once you give that delegation, or once you give that part to another party, then you need to still have some administrative space to make sure that those delegations are recorded in that administrative space. Now that administrative space is what we call a zone, right? Zone. So in DNS, we use this term called zone quite often, okay? But simply you can consider this zone as an administrative space. So in this diagram, you can see that you have this root on top of this hierarchy. So the top of the DNS is what we call root. So root itself is a namespace, right? It is a database managed by the administrator of root. And in another term, we can also call this space as zone. So we call it as the root zone, right? Root zone. So root zone means the database or the space managed by the root administrator. Now root has delegated part of its responsibility to another party. You can see there are different parties here, like .com, .mm, .coffee, like that, right? So these are all top-level domains, right? We call those as TLDs, or top-level domains. Now, earlier I was referring to some different types of top-level domains as well, if you remember. I was telling about generic top-level domains, or GTLDs. So .com is one of those generic top-level domains. And then .coffee, it is a new generic top-level domain, which was delegated during the last 10 years, right? And then we have .mm, which is the country code top-level domain for Myanmar. Now, there are many other CCTLD delegations, countries who has got 2-letter country codes delegated. So this is again a standard. Now, when I say a standard, that means it's an international standard, ISO standard. So every country gets a 2-letter country code for that particular country or the territory, right? So for Myanmar, this has been delegated a long time ago. It is MM. So MM is a country code top-level domain delegated to Myanmar by the root, okay? So MM has a space. So MM is managed as the country code top-level domain operator for Myanmar, and there is a space. And if Myanmar wants, they can further delegate this into com.myanmar or net.myanmar or mm, edu.mm, like that, right? So it is up to the administrator. Now, there is also some other string here. You may be wondering, what is this? This is actually, even though it is specified here with some characters that you may not be able to recognize, but it is actually what we call an IDN delegation, internationalized domain names, because we can also have these top-level domains or the domain names in non-Latin characters. I use the term non-Latin to say that it is non-English, basically, right? Because English characters are also basically Latin words, Latin characters, right? So when I say non-Latin, that means you can also consider it as non-English. So for example, in Myanmar, you have your own scripts, Myanmar scripts, and then you can have domain names using your own language scripts. So if you want to have some Myanmar script, a domain name that consists of Myanmar characters, you can still get relegation from those characters. So there have been some work happening in the IDN space in relation to Myanmar scripts. So this work has started some time back, right? So this is something for you to understand as well. So these are what we call internationalized domain names, so IDNs. And then further, you can see these delegations. Now I have example.com, right? So that means .com has given part of its namespace to example, and that is what we call example.com, okay? And similarly, you go all the way down, right? And we have top level domains, second level domains, third level domains, and so on. Now there is also, if you are an engineer, you also have to deal with something called FQDN. FQDN stands for fully qualified domain names. Fully qualified domain names, because in your configurations, right? In your configurations, when you have domain names, you have to specify those domain names as fully qualified domain names, because you need to specify the root as well, the absolute path. Remember, if you are familiar with Unix systems, it is very much similar. The Unix file system is very much similar to this. And in the Unix file system, if you want to go all the way to the absolute path, you go from bottom to the top. So here it is the same, right? If you want to go from bottom to the top, you would say www.example.com and then dot, because top of the DNS tree is root. So here you can see that www.example.com dot. The last dot here, we call it as the trailing dot. So trailing dot refers to the root. I'm mentioning this, I'm actually emphasizing on this point mainly because these fully qualified domain names are very important in the configurations. If you miss this dot in your zone files or in your configurations, it can create a lot of issues. It will give errors. You may not be able to run your DNS properly, right? You may not be able to run your DNS name server software properly, right? So that is why these fully qualified domain names are very important in the DNS configurations, okay? Okay, now moving on to the next slide. Now this is how a DNS query gets resolved. So there are DNS components that we have to look into when you think of DNS query resolution. Now here, if you see my pointer, right, you see this client, right, the device. Say, for example, it can be yourself. You might be having your device, the mobile phone. The mobile phone, you have your apps, right? So all these are apps means applications, right? So these applications, they interact with your operating system in your device. In your operating system, you have what we call a stub resolver running, right? So this is built into the operating system. Now the stub resolver communicates with your applications. Now, if I take an example, say a browser is an application. So if you want to browse a certain website, say www.example.com, right? If you want to go to www.example.com, so you need to type that into your browser, and browser is the application. So the application will send a query, or what we call an API call, to the stub resolver, asking for the IP address of www.example.com web server, because you want to get to that web server to download the web page, right? Now, IP address is very important in terms of data communication. You don't need DNS to do the, send the data from one host to another host. Without DNS, you can send packets from one host to another host, but you need an IP address. So that is why IP addresses are very important in data communications. We use the protocol called TCP/IP in data communication, TCP/IP. So in TCP/IP, we have 4 layers. You may have studied these in the university, right? So we have 4 layers in TCP/IP. Top layer is applications. Second layer is transport. And the third layer is network or the IP. And the last layer is physical, right? So you have to have physical network, like it can be cables, Wi-Fi, all those, these are all the physical mediums, right? You need to have that network to send these data packets. And then in the IP layer, in the network layer, you have to have the addresses. So these are the IP addresses that we are talking about, right? You need to define the source IP address and the destination IP address. This data has to go, right? From what source to what destination, what IP address. And then in the transport layer, we package it, right? We package it, package all these data, the bit streams into packets, right? And then on the top layer, right, that's in the application layer, it interacts with the application, okay? So that if I want to actually say, for example, if I want to send an mail or something, email or something, you have to have an email client as the application so that you can retrieve it, okay? So that's how the data gets transferred. So anyway, I was telling you about the IP addresses, importance of the IP addresses. So you have to have IP addresses, but DNS is in the application layer, not in other layers, right? Now, DNS is there for humans, not for the machines, okay? When I say machines, that means, machines can deal with IP addresses easily. But humans, we cannot remember these IP addresses. That is why we need DNS, that we can deal quite easily, right? So DNS maps IP addresses to something we can remember, like names. So coming back to my slide, I was telling you that in your device, you have applications like browsers, other apps that you have, and so on, okay? So these applications, they interact with the operating system, the stub resolver, asking for the IP address. If you open a certain app, that app has to communicate with the server, right? So to do that, your device need to know the IP address of that server. So that is why the application is asking the stub resolver, give me the IP address, right? But how can then the stub resolver find this IP address for you or for your application? So the stub resolver send a DNS query to what we call the recursive resolver. Right? So these recursive resolvers are operated by the network operators. So network operators, ISPs, mobile operators, and so on. They are the ones who are typically running these recursive resolvers. But there are other organizations as well. There are public resolve operators. Sometimes if you're from universities also, they run recursive resolvers. Banks, sometimes they run their own recursive resolvers for their users. But generally, it is the ISPs, mobile operators, and so on. They are the ones, the network operators. They run recursive resolvers. So the applications, the clients, they interact with the recursive resolver and ask for those IP address details. So then the recursive resolver send queries to what we call authoritative name servers. Authoritative, this term is quite important, authoritative. Authoritative means you are authorized to give an answer, right? So remember earlier we discussed that you're managing your own namespace, the zone, right? So if you are managing a zone or your own namespace, administrative space, you're authorized to give answers for that space. If you are managing the root zone can give authorized answers for the data that is in the root zone. Similarly, if you are managing .mm zone or .mm administrative space, you are authorized to give answers for that .mm administrative space. Similarly, if you are managing example.mm administrative space or the zone, you are authorized to give answers for the example.mm space or the zone. That is why these servers are called authoritative name servers, because you're authorized to do that. So the recursive resolver, when the client or the device asks for this question, give me www.example.com. First of all, we have to find the IP address of that. So the query would be sent to the root servers first. Why? Because root is the top of the DNS hierarchy. If you remember the previous diagram, we had root as top of the DNS, right? So that is why the query is sent to the root servers first. And then root servers would respond with a referral, right? Root servers will not give an exact answer about that IP address that the client was asking, but root server would give a referral to the top level domain. Because if the question is give me the IP address of www.example.com, or example.mm, then root server will give a referral to .mm, because .mm delegation is recorded in the root zone. So the root knows how to get to the .mm servers. So that response will be returned to the recursive resolver, and then recursive resolver can go and talk to the .mm servers, right? And then .mm servers would do the same thing. They give a referral to the next level, because example.mm is delegated by the .mm servers. So the IP addresses of example.mm servers are recorded in the .mm server. Now that is being returned to the recursive resolver. And then recursive resolver can go and talk to example.mm server. And then once the question goes to example.mm server, example.mm server can give the exact IP address of www.example.mm, right? And then that answer gets recorded in the recursive resolver. The answer will be saved in the cache or in the memory of the recursive resolver, and that answer is given to the client, right? Because it is the client who asked that question. Once the client gets the IP address of www.example.mm, now the client can establish a connection with the example.com or example.mm web server, right? And download the web page. So to establish that connection, DNS has helped, or these recursive servers and authoritative servers has helped to establish that connection. Once the connection is established, after that, it is pretty much a web query, right? Because you just send a query, It's a TCP based query, right? And you get the web page. Okay. Okay, so I hope this process is clear to you. You have to understand this very clearly. That is also why I try to actually explain this. If you have to understand DNS fundamentals, this process is very important, right? Now let's go into talk about DNS servers. Now DNS servers, there are different types of DNS servers. I think we already discussed that in the previous slide. We spoke about root servers. We spoke about authoritative servers. Now, root servers are authoritative servers because they are authorized for the root zone. And then similarly, if you are running any zone or if you're managing any zone, you are supposed to run authoritative servers for that zone. Now, these authoritative servers are defined as primary and secondary servers. Why primary? Why secondary? It is for redundancy. So you would run a primary name server and as a backup as a secondary name server. But you would operate both, right? If you want, you can run multiples of these servers. Then you have more redundancy. Now, if you, this is just a diagram you see here, this is actually the root servers that we have in different places globally, right? Root servers, they are located in different places, mainly for redundancy purposes, security purposes, and stability purposes, resiliency purposes, right? All that can be achieved when you have all these root servers scattered in different parts of the world. We can make sure that even though one root server goes down, you still have access to the root zone. Root zone still functions. So that is why we have many root server instances, including in Myanmar, you have root servers. Then we also have recursive servers. Now, recursive servers are, I also explained you earlier, that they are run by the network operators like ISPs, mobile operators, and so on. We call those servers sometimes as recursive resolvers or caching servers, but the function is same. Caching servers, we call those as caching servers because they cache the answers. They keep the answers in the cache. Now, I can actually try to quickly do a very quick demonstration, given that you are operational people, to show you this thing what we discussed. So let me stop my slides and I'll use my browser, right? Do you see my browser window? Do you see my browser window?
Yes.
Okay, good. So if you go to www.rootservers.org, you can see where these root servers are located, right? And you can see, there are many root servers scattered. If you can zoom into this, let's try to zoom into Myanmar. Yeah, so you can see this is Myanmar, right? So this is Yangon. So you can see that in Yangon, we have few root server instances, right? So there are letters here. There is D, F, E, L, K. So these are all, by these letters, we define the root server name, right? If you go further up, you can also see there are root servers located here as well. I believe this is Mandalay, right, where you are now, okay? So you have F, L, okay? So these are root server instances located in Myanmar, right? Now, if you do not have these root servers in Myanmar, remember earlier when we went through that query process, the recursive servers has to go and talk to root servers. So if you don't have root servers in Myanmar, the queries have to go to root servers outside, somewhere else. It depends on how your network operator is connected. Depends on the network topology and the peering, right? But if you don't have a root server, most likely your queries will have to go outside Myanmar, right, to get it resolved. So, but having your root servers in Myanmar, multiple root servers in Myanmar like this, can make your DNS responses faster, right? It makes it faster because root servers are in Myanmar, and also if there are different network operators hosting these root servers, then whoever the clients connecting to those networks, they can get much faster response time, the DNS response time, comparing to where you don't have a root server in your country, right? Now, again, coming back to these letters, now these letters are specified based on the root server naming convention, because root servers also have to have some name. The naming convention is a certain letter dot root servers .net. So root servers, they have a name called a certain character, certain letter, A, B, C, like this, and then dot root servers .net. That is the name, the naming convention of the root name servers. So we have root name servers called A dot root servers .net, B dot root servers .net, C dot root servers .net, like that, right? All the way up to M dot root servers .net. We stop at M mainly because if you go beyond that, there are some technical limitations where we may not be able to include all those data in a single packet, right? So that is why we stop at that stage. But if, it doesn't mean that you only have 13 physical root name servers, because from A to M, we have 13 names or 13 letters, but it doesn't mean that there are only 13 root name servers, right? You can see that as of today, as of September 8, right? You have 1,866 root name server instances around the world. So even though, of course, we only have 13 names, we have 1,866 instances covering the whole world, right? So this is based on the anycast routing, right? In fact, I have seen in the agenda that you are going to have an anycast tutorial after this session. So you will learn more about anycast. So I'm not going to explain you here about anycast. So, but through anycast, we can find out what is the most optimal server that we can reach. So these root servers are implemented as anycast servers so that we can get to the most optimal or the most nearest in a way so that we can get the faster responses from DNS. So now you can also see who operate these root servers. A is operated by VeriSign company, right? B is operated by the Information Sciences Institute. This is actually university. It's one of the universities in the United States, University of California. C is operated by Hogen. This is an ISP over there. D is operated by another university called University of Maryland, and so on, right? So you have all these different operators. They operate different letters. If you see the L is operated by ICANN, okay? So this is why these L root servers are called ICANN managed root servers, or simply we call those as IMRS, ICANN managed root servers. These are the locations for those, right? So you will see that, remember earlier we saw that 2 of these root servers located in Myanmar. So in fact, some years ago, we have been having some correspondence with Kind, and then we have these root server deployment, right? The L instances, 2 of those in Myanmar, right? So if you see, now you are in Mandalay. So this is, here you have Mandalay, right? So this is one of the L instances in Mandalay. And also you have another one, Yangon, right here. You can see it is Yangon. So like this, you have, if you have some root server close to you, you can actually get faster responses from the root servers. Now, all these root servers, they have their own IPv4 prefix, right? The IPv4 address, and then the IPv6 address, and the AS number. So these are the details for the ICANN managed root servers, IMRS. Similarly, the other root servers, they have different other IP addresses, IPv4, IPv6, and the AS numbers. But of course, as I said, all these prefixes are announced from different locations so that you have different entries in the routing table, and then you can get to the most optimal route to get to that root server, right? So I hope it is clear how these root servers gets operated. Now I'm coming back to the slides. Right, so this is where we were. That was here. Yeah, I hope you can see my slide. So this is what I was showing you earlier, right? This is what I was showing you earlier, the root server map. All right. Now, I also mentioned you about this delegation, right? Delegating a zone. This is how you delegate a zone. So if you are operating, say, if you're operating example.com, if you're managing example.com, and if you want to delegate part of your responsibility, say, to training.example.com, it's a sub-delegation, right? It is a sub-delegation. You're giving part of your responsibility to another party. Now, if you want to do that, this is how you do it in your zone. So you have training.example.com. This is your child zone, right? This is a child zone, and the parent zone becomes example.com, and the child zone becomes training.example.com, right? So the child zone is delegated to a certain name server. So the child has to provide the name servers for their zone, and then the parent would publish that. So the parent will have these kind of records in the parent zone with NS. So NS stands for name server. So parent refers that child, which is training.example.com database or the zone, is delegated to these name servers, ns1 training.example.com and ns2 training.example.com. Now, child can provide any number of name servers that they have, right? And then the parent has to add these name servers into the parent zone in the delegation. Now, these servers are authoritative name servers. See this ns1 training.example.com and ns2 training.example.com. They are authoritative servers for the training.example.com zone. Okay. And then how to get to this ns1 and ns2? That's the next question. Because now parent has published these two name servers, ns1.training.example.com, ns2.training.example.com. So we have to, if we have to get to these name servers, we have to know the IP addresses of these name servers, right? So we have to then publish, or we, when I say we, that means the parent in this case, because this is the parent zone. So parent has to publish the IP addresses of this ns1.training.example.com and ns2.training.example.com. Now, these IP addresses are called glue records. I mean, the publication of those records are called glue records. So in the DNS, we have this term called glue records. That is a very important concept, again, for administrators. You have to publish the glue records. If you don't publish the glue records, we cannot get to those name servers, right? And remember, the glue records are published only if the name servers are in the same hierarchy. If it is outside the hierarchy, you don't need to publish the glue records. Now, when I say same hierarchy, that means you can see that training.example.com and example.com, they are in the same hierarchy, right? Say if the child says, I also have a name server saying ns.anotherexample.com, right? ns.anotherexample.com. So you can see that another example and example, they are two different zones, right? So the parent does not need to have a glue record for another example.com because it is outside the hierarchy. Parent only needs to publish the IP addresses of ns1.training.example.com and ns2.training.example.com. No need to publish the IP addresses of ns.anotherexample.com, right? So this is the concept behind glue records. Now, so to summarize what we discussed, we have a parent zone, we have a child zone. Parent zone is example.com and the child zone is training.example.com. And this is the parent name server, ns.example.com. And say if the child name server is ns.training.example.com. So in the parent name server, in the zone file, parent has to add the NS records and the glue, right? So parent has to add NS records given by the child and their IP addresses, the glue records. And make sure there is no other data from training.example.com in the parent zone, okay? Because training.com, once I give something to you, say I am the parent, you are the child. I manage example.com and you manage training.example.com. So when I give you the training.example.com, I don't need to keep any data related to training.example.com in my zone because I'm delegating everything to you. You take care of training.example.com. So I am not supposed to have any data related to training.example.com, right? I only need to know how to get to you. That is why I'm publishing your name server name and the IP address, glue record. But after that, whatever the data related to training.example.com has to be published in the training.example.com zone, in the child zone. So Champika has to set up minimum of 2 name servers, right? And then create a zone file with the NS records, and then add all the training.example.com data into that, because you are managing your own zone, right? So I don't put, as the parent, I don't put any zone records in my zone that is related to you. You have to put all your zone data, okay? So I hope this is this is clear to you, because this is very important concept to know in DNS. Okay, now let's go into talk about the zone file management, because once your name servers are properly delegated, next step would be to create the files. Now, to create the zone files, you have to understand about zone data, or how, in what format you're going to put this zone data. We put this zone data in a format called resource record, right? Or simply we call it as RR, resource record. So this is how a resource record looks like. It has got 5 fields, right? It has got 5 fields in that. We have label, we have TTL, class, type, R data. These are the 5 fields. So label, say if you want to publish your web server IP address, if you want to map your web server, which is www, to its IP address, this is IP address, IPv4 address. So you would create a record called www, right? Then you have this field called TTL. TTL stands for time to live. So time to live means, remember earlier we discussed that all these zone records gets cached in the recursive resolvers, right? Recursive resolvers keep these records in their memory. And now, as the administrator, you can define for how long these records should be there in the cache. So you can put a value here. Now, this value is in seconds. So in this example, you have put a value 3,600. That refers to in seconds here. So 3,600 seconds mean it's 1 hour. So you are saying when this www record gets cached in the recursive resolver, it will stay there for 1 hour, right? So there will be a timer. As soon as the recursive resolver gets this data and put that, put that into its cache, there'll be a timer that runs so that it can keep this data for a time of 1 hour, because you have specified the TTL as 1 hour, 3,600 seconds. Okay, now then we have another field called class. Now this is actually, nowadays you don't need to really worry about this. This class was used long time ago when the DNS started. Because when the DNS started, there were a few classes called, there were a few other classes, and we primarily use this for internet class, right? That's why we have IN to specify internet. But nowadays, by default, everything is internet. So we use this class, the default class, as internet. So you don't have to really type IN here or specify IN. Even if you don't specify IN, class will be picked automatically as IN, internet, okay? Then we have a class, then we have a field called type. Now type is A, because A stands for address record, address. You are specifying an IPv4 address, because this 192.168.0.1 is an IPv4 address. So if you want to specify an IPv4 address, you would specify it using the type A. But if you want to specify an IPv6 address, then the resource record type would be A, what we call quad A, like you can see it here. So these are some most common types of resource records. If you want to define an IPv4 address, we use A record. If you want to define an IPv6 address, we use quad A record. If you want to specify a name server, we use NS record. If you want to specify some administrative details, for that we use actually a record called SOA. SOA stands for Start of Authority, because as the authority, we can specify who is authorized to run this zone, right? The administrative details. What is the primary server details? What's the email ID? You know, these kind of administrative details can be specified in the SOA record. MX record is used for mail servers, mail exchanges. If you want to define your mail server, we use MX record, right? CNAME is used for alias, because in DNS we can create a lot of alias. Alias means similar names. We use this type called CNAME. CNAME stands for canonical name, or in other words, alias. So these are different types of resource records. It doesn't mean we only have this many, but there are so many other so many other resource records that we use in DNS. Everything is not specified here, but if you want to see many other resource records we use, you can go to IANA.org website and find out more details, what type of resource records we can have, right? Then we also have another field called RData. RData stands for resource data, right? So this is actually the actual data that you are specifying in this mapping. So you are mapping your name, which is www, to an IPv4 address called 192.168.0.1. So this is the actual data, right? So similarly, every resource record has got an RData field, resource data field, where you specify the data related to that mapping. Okay, so this is how a resource record looks like. And in a zone file, you will find many resource records like this. Now, in this slide, I'm showing you some example zone file, right? Example zone file. So you'll see that this is how a zone file looks like. You can further simplify some of those resource records that we discussed earlier, the fields. Remember earlier when we went through that, we had 5 fields. Now, if you are going to have the same TTL for every record, remember the TTL that we said, when it gets cached in the recursive resolver, it is being kept in the cache for 1 hour, for example, if we put 3,600. So that TTL, if it is common to every record, you can define it globally. So that's what we have done here. In the zone file on the top, we have had a statement called $TTL, which means it is applicable to all the records. In this case, it is 86,400 seconds. So that is equal to 24 hours or 1 day. So that means when any of these records, right, any zone data gets into a recursive resolver, it will be saved in the cache for 1 day, right? So that for that whole day, recursive resolver doesn't have to go and talk to root servers and top-level domains and so on. During that day, any question that comes related to any zone data in this zone file, throughout the day, recursive resolver can respond using its data in the cache. It doesn't need to go and talk to root servers or TLD servers and so on, because we have a TTL of 86,400, which is 24 hours, 1 day. Okay. So I hope that you got this understanding, this meaning, right? And then similarly, if you want to further simplify this, remember earlier we said fully qualified domain names, you can define your zone, right? The fully qualified one as origin. So here you say $origin example.com dot. Make sure you put the trailing dot, otherwise it will not be a fully qualified domain name. Okay. So once you define the origin here, you don't need to specify the origin in these labels, right? In actual fact, this label should be ns1.example.com dot. This label should be www.example.com dot. ftp.example.com dot, right? So rather than typing example.com dot in every record, you would specify that here $origin example.com dot, so that you can get rid of example.com dot part from all these records. It simplifies our zone file. Okay. Yeah, so that's the idea of this origin record, right? Origin statement. And then we have this at symbol. So this is a symbol or a regular expression we used. The zone that you refer here, there is a pointer pointing to your configuration file, because in your name server software or the name server implementation, when you run your name server, there is also a configuration file that you have to have. So this zone file has to have some communication with that configuration file. So this is why we are creating a pointer saying that in the configuration file, the zone what we use is this particular zone, right? And then this is a resource record. IN is that internet class that I was talking about. SOA, that is the resource record type, start of authority. I told that under the start of authority, we can provide the administrative details for a zone, right? Administrative details. When I say what do you mean by administrative details? That means things like your primary name server, right? So this is your primary name server, ns1.example.com dot, right? Fully qualified domain name. And then this one is your email ID. But it doesn't look like an email ID because usually email ID has an @ symbol in the middle. But in the zone file, when you have to specify that at the rate expression has to be converted to a dot. So you would say postmaster dot, not postmaster at example.com dot. Okay, but the software knows how to use this first dot from the left side, and that will be converted to an @ So this becomes postmaster at example.com dot, right? So this becomes your email ID. So it's important to publish your email ID of the DNS administrator, because in case if we have to contact the zone administrator for any purpose, say if there is some issue, or if some email server is down, or if some zone record, if there is some abuse or anything, right? If we are to contact the DNS administrator, we have to know the DNS administrator's contact details. That is why we put this email ID here. So make sure that if you are running a DNS zone, you put your proper contact details so that if there is some emergency, if there is some situation, the administrator can be contacted, right? In some organizations, they have not changed this field for so many years. Maybe the administrator has even left the organization, but still it refers to that old administrator's email ID or something like that, right? So make sure that this email ID field is current, right? And then there are some further fields in this SOA record for administrative purposes. This is what we call a serial number, right? Serial number is for, remember earlier we discussed about primary and secondary name servers, the authoritative name servers. We have to make sure we have consistency between name servers, right? Name servers has to be consistent. If I am the primary and if you are the secondary, my data and your data has to be consistent, because the queries can come either to me or either to you. So we have to make sure that we give consistent answers. If I give you if I give the recursive server one answer, and if you give another answer, that means they are not consistent, right? So this is why if we are managing primary and secondaries for a certain zone, we have to make sure both of us are consistent. So how can we maintain that consistency? We have to have some version control, right? So to do this version control, we use a serial number. That is why we use a serial number here, right? So both our serial numbers has to be same. So if I am the primary, I am the one who is updating my primary zone, my master zone, and then I am supposed to actually come up with a serial number, and then you need to come and check what is my serial number, and then you get my zone data, right? This is what we call a zone transfer. You do a zone transfer. So once the zone transfer happens, that means your data and my data are consistent. Then both of us will have the same serial number. Later on, if I update some new data, new records to my zone, I will increase my serial number. If I increase my serial number, right? If I increase my serial number, you know that your serial number and my serial number, they're not same because I have increased my serial number, right? So then you know that some zone update has happened, so that it will trigger for you to do a zone transfer from me, because your serial number is lower than my serial number, right? So anyway, this serial number is actually to maintain the consistency between name servers, the primary name servers and secondary name servers. And then there are other parameters here. I won't go into too much detail given the time we have, but these are what we call timing parameters. Timing parameters. These are also for secondary, right? If the secondary, gets the data from the primary, how can it manage this consistency? For example, if I am down, right? If the primary is down, how can you get this own data again? So you'll see this value is called refresh value. That means you will keep on, time to time, you will come and check me, right? And in case if I'm down, you will do some retrying, okay? And then you can do this retrying until some expiry, right? Until a certain period of time, you will retry, okay? So like this, we can define these values to maintain that consistency between the primary and the secondary, okay? And then we specify what are your name servers for the zone. So if I am the zone administrator for example.com, I will say my name servers are these ones, ns1.example.com, ns2.anotherexample.net. So now you can see that they are two different zones. Remember earlier I was telling you about glue records, right? So this is where that will come into the picture. Because I am running example.com, right? I'm running example.com. I don't need to specify the name server IP address of this one, ns2 another example.net, because it's outside my zone, right? So I only need to specify the glue record of this ns1.example.com, right? Which is this one. So like this, you would actually create your zone data in your zone file. If you have a mail server, you create an MX record, mail exchange, okay? And then you can also provide some priority for mail servers. If you have multiple name servers, if you prefer some mail server, if you have some more preference over one mail server, then you can give some preference value there. So like this, you can define your records in your zone file. If you have some, say in this case, CNAME as a CNAME record. Remember I mentioned you earlier, CNAME means canonical names, alias. So you are saying that you have a server called FTP, right? ftp.example.com, and you have an alias called www.example.com. So which means whether you say FTP or whether you say www, you are referring to the same name server, right? Sorry, it's the same FTP server or the same web server, okay? And then you also have, say in this case, there's a web server defined with a certain IP address, there's a record. So you can actually create these zone records in your name, in your zone file, right? I hope now this has given you some idea about zone files as well. Now, especially if you are a sysadmin, if you are a DNS administrator, you may have to deal with this file quite often, right? You may have to edit this file, add the zone records, delete some zone records, right? And so on. But some of the administrator may do this through some web interface. They may not directly edit the zone file, or they may not, uh, mm, basically deal with this file directly. They have a control panel like a web interface. If you want to add a record, or if you want to add a NS record or something, you just add that in your GUI interface, GUI interface, right? Saying, okay, I'm adding this web server into my zone. That's it, right? So what you see is actually a graphical based interface, not a text file like this, or you don't have to go and edit this in that case, right? You just add a record. So whatever the case, it is good for you to have some understanding. This is how the zone records look like, and this is how you edit the records. Okay, now let's go and quickly talk about some propagation of DNS data. Now, referring to that early examples that I was talking about, so you have your primary name server. It is an authoritative name server. Then also you have your secondary name servers. Now these things can be in different places. Say you are in Myanmar, right? So primary could be in Mandalay, right? Your primary server could be in Mandalay, and one of your secondary could be in Yangon. And then another secondary could be even outside, maybe in Singapore, for example, right? So if you have some name servers scattered around, then let's see how these queries get to your name servers. Say you have a client here, right? The user, just a user, right? Say myself, I'm a user. I'm sitting in, say, for example, in some other country, right? And I have a caching name server, so I'm connected to my ISP, right? So my ISP is providing me a caching name server. And then my query goes to that caching name server, the recursive resolver that my ISP operates. So now my ISP try to get to any of these authoritative name servers. Say, for example, if I'm in Singapore, for example, if I'm in Singapore, it is much easier for me to talk to the name server in Singapore, right? Rather than sending a query to Yangon or Mandalay, right? If say, for example, if I'm a user in Yangon, right? If I'm a user in Yangon, that's more likely that my query, if the recursive server is in Yangon, it's more likely that the query goes to the Yangon name server, right? If I'm if I'm sitting in Mandalay, it is more likely that my query goes to the name server which is in Mandalay. So you can see that, depending on where you're located, where the client is located, where the caching server is located, your queries going into different authoritative name servers. So that is also why I was telling you earlier, the consistency of data between these authoritative name servers has to be consistent. We cannot have one type of data in this primary server and another type of data in the secondary server and another type of data in this secondary server. That is not good, right? So we have to make sure that all the data across these primary and secondary name servers are consistent, right? Now, but the thing is, DNS, remember, it is a hierarchical database, and different parts of different components of this database, different namespaces are managed by different parties. Root zone is managed by the root name servers. TLD space is managed by the TLD, different TLD, are the registries, and so on, right? So if there are different infrastructure, different servers keeping this data, it takes time to propagate this data from one place to another place. Now, the zone file is updated by the primary administrator, right? The primary server. Now, this update can happen through a registry database. Say, for example, let's look into the registry. Say, let us think that this is .mm, right? Now, .mm, they run a registry, okay? So we have a database. So when the .mm database gets updated, say if they're going to delegate a new second level domain. So for that new second level domain, the registry database has to be updated. The zone file has to be updated. So once that update comes in, primary server will get updated. Once the primary server gets updated, this data has to go to secondary servers, because all the secondary servers has to come and pick this data, right? Now it takes time. If you remember, earlier I was referring to something called a refresh time, right? In that SOA record, there was something called refresh time. So refresh time is the time that secondary comes to the primary server. If you specify the refresh time as, say, 12 hours, that means after every 12 hours, the secondary server will go and check the primary server. Check means what? Check the serial number. Remember, I was also referring to a serial number. I said that you have to maintain a consistent serial number, the version control, so that when the secondary comes and check the serial number, if the serial number is same, if the primary and the secondary serial numbers are same, then the secondary would not do a zone transfer, because it assumes that, okay, it's the same data that I have. But if the primary serial number is higher, then secondary knows that there has been some zone update, okay? So then the new zone update will be received to or there will be a zone transfer, so that the secondary can be updated with that, whatever the update, right? So we have to manage the consistency. So you have to do that. Of course, you may have to wait for that refresh time, 12 hours. So it is the administrator of the primary who set these timings. If the administrator sets 12 hours, that means if, say, for example, now the time is 3 o'clock, 3 p.m., and then only if this zone file is updated at 3 p.m., and if the secondary has to get this data after, say, 12 hours, that means the actual update will get to the secondary server, but in tomorrow morning around 6 a.m., right? After 12 hours. Or sorry, not 6 a.m., 5. If it is 3 p.m. now, that means it's 3 a.m. At 3 a.m., it is going to get this data, right? So after 12 hours. And so for that, during that time, so from 3 p.m. today to 3 a.m. tomorrow morning, say 9 p.m. at night today, if this user is going to be, some user going to be in Yangon or somewhere, right, trying to access this data from the Yangon server, may not get the correct answer at 9 p.m. Or if a user is in Singapore, for example, trying to get to this server, because it may be contacting the server that is in Singapore, at 9 p.m., still it has not received this data because the refresh time is 12 hours. It has to wait until 3 a.m. to get that data, right? So the whole point I'm trying to explain is that it takes time for the DNS data to transfer or to propagate. There is also something called TTL expiry. Now, this TTL also I explained to you earlier, time to live values, TTLs. Once that answer gets to the cache, it will stay there for the time that you specified in TTL. If you specify your TTL as 1 day, remember in our example zone file, we had a TTL of 1 day. That means when that data gets here, it will remain there for 1 whole day. Say at 3 a.m., this caching server gets the data at 3 a.m. It will be there next day, 3 a.m., right? If it gets this data, say tomorrow, 3 a.m., this will be there day after tomorrow until 3 a.m. So until that time, this client will be answered based on the information in the cache. So this client, until day after tomorrow, 3 a.m., it's going to get these answers from the cache. It is not going to get the answers from these authoritative servers. So in actual fact, until day after tomorrow, 3 a.m., this client may not get the right data, okay? So this is why it may take some time for DNS data to propagate, right? But then you can actually flush the caches, okay? You can also flush the caches, and also there are things called notifications. For example, you can neglect these refresh times, and the primary can send some notifications to secondaries. That means whenever some new update happens, primary can send an update to the secondary saying that, or a notification saying that I have got new data. So you can now do a zone transfer and get the new data. Okay, so you can do things like that, but then of course then the traffic would increase because every time you do some zone update, there are going to be some zone transfers between these name servers. So because of that, it is always good practice actually to use these parameters in a consistent way. And then you know that every day at a certain time, this zone data gets updated into the secondaries or the, your authoritative servers, the caches, and so on. So, and you also put some proper times based on the expected changes in the zone so that the TTL values are quite consistent, so that it doesn't keep in the caches for very long times or very short times. Okay. Yeah. So anyway, the whole idea or the bottom line, what you have to understand here is that it can take some time to propagate DNS data from one place to another place, or one server to another server, and then you need to be aware of this. All right. Okay, I think I just want to very quickly mention you something on the reverse DNS as well, right? Before we, I know it's now almost getting to the closing time. So, but reverse DNS is now all this time we were doing mapping the names to the numbers, right? www, a record, IP address. But there is also other way around, which is what we call mapping numbers to names. This is what we call reverse mappings. Now, especially given the security situation today, the security, because it's something very important, we have to make sure that are we getting these queries from the right place. If you are sending me a query saying that I am host.isp.com and my IP address is this, I have to make sure to check whether are you really having that IP address, right? Because you can spoof the IP address. So this is why we have to have this mapping called reverse mapping, reverse DNS. To do that, you have to actually create what we call a pointer record, right? Usually we have a record, host.example.com maps to an IP address. A record. This is what we call forward DNS. But then you also have to map this IP address to the host name, and that is done by a record called pointer record, right? PTR record. So you need to create that. Now, if you are mapping an IPv4 address and IPv6 address, there are two different top-level domains and subdomains in the DNS tree. For IPv4 addresses, we have a subdomain called inadra.arpa. .arpa is the top-level domain. Inadra.arpa is the subdomain. For IPv6 addresses, we have something called IP6.arpa, right? ARPA is the top level, and IP6 is the subdomain for IPv6. So you need to actually do this mapping. And once you do the mapping in the DNS tree, it looks like this. So it's the same tree. You have top of the tree is root. Then, like .com, example.com, we went through this earlier. But when you do the reverse mapping, you have this ARPA, that is what we call the reverse domain. Under the ARPA, we have a subdomain called inadra for IPv4, and for IPv6, we have another domain called IP6. I'm not showing IPv6 here, but because most people use IPv4 addresses. If you're using IPv4 addresses, then you put your IPv4 address along this hierarchy. If you have 192.0.2.7, then you put it like this, 192.0.2.7, and then you create a pointer record between this fully qualified domain name, which becomes 7.2.0.192.inadra.arpa. That is mapping to host.example.com. Right? This is what we call a reverse mapping. You have to do this reverse mapping. Otherwise, especially, given that if you are an ISP, if you are a network operator, if you are a mobile operator, when you get these IP blocks, say from APNIC, for example, if you're getting these IP blocks, you need to actually, APNIC will create a delegation for you. And then you have to provide your name server details to APNIC so that they can create a delegation in their reverse zone, because APNIC manages whatever the /8, right? Like this, these blocks are managed by APNIC, and then you are given a smaller block inside that. So you will have to create the pointer records for the IP addresses that you're using in your block, right? So this is something very important for the ISPs and mobile operators. Okay, now we have only like a few more minutes. I also actually want to show you something else very quickly before we wind up. That's called the kindness platform, that what we have at ICANN. This is for best practices, DNS best practices. Hope you can see my slides here. So if you want to actually follow the DNS, especially the security best practices, we have a framework called kindness, right? It is spelled as KINDNS. It has a meaning. This is the sort of full meaning of kindness. Basically, knowledge sharing and instantiating norms for DNS and naming security. I mean, don't worry about the full abbreviation, but just use it as kindness. The whole idea of kindness is to make sure that operators, they are applying the best practices in their DNS operations so that they can manage the DNS operations quite securely according to the best practices, right? So that's the idea of kindness. So kindness can be, when you use kindness, these best practices, you can test yourself under different categories. You might be a top-level domain or critical zone operator. Say, for example, if you take .mm. If you are a .mm, you are managing .mm TLD zone, or in fact, it is a critical zone. Sometimes in some countries, you may be managing some critical zones that is affecting the whole country, right? So if you're managing those critical zones or top level domains, you may be operating the authoritative servers for that. Or you could be managing second level domains as well. Say, for example, example.mm or example.com or your bank.com. So if you are managing that, you can practice the principles that is specified in authoritative operator category in kindness, right? And similarly, if you're operating recursive name servers, resolve operators, closed and private resolvers, this means like for your organization, because sometimes some banks, some universities, they run their resolvers, but only for their users. If you are if you are an operator, a bank, right? If you're operating your network in a bank, you could be running resolvers only for the bank users. So you are operating a closed resolver and a private resolver, right? But if you are ISP or mobile operator, you are operating a shared private resolver. That means you are only sharing it for your own customers, own clients. Or you could be operating some public resolvers. Public resolvers means to anyone. Even myself, I can use your resolver, right? So if depending on these categories, you can practice different best practices related to DNS. Okay, so we highlight those in kindness, so you can access the kindness system. To access the kindness system, what you can do is you can go to www.kindness.org. Maybe I'll quickly show you that. If you go to your browser, if you go to your browser and give kindness.org, you get to this web page. This talks about kindness. Remember, if you go and see these operator categories, you can see those different operator categories that we discussed. You can be an authoritative server operator. You can be a recursive server operator. Whether even inside that you have subcategories like private resolvers, like I said, like banks and so on. Shared private resolvers for ISPs, mobile operators, and so on. So if you are a bank, sorry, if you are a ISP, for example, right? So you might be operating a recursive server operator. You are operating shared private resolvers. So you could then see these are the practices you should be deploying in your environment. Say, for example, practice one, DNSSEC validation, right? This is a must for, you have to enable DNSSEC validation in your recursive resolvers. So if you you may have to, of course, understand what is DNSSEC and how to configure validation and all that. But this is a good practice that you should be doing that. And similarly, you have to have access controls, right? ACLs. So these are different practices that we would highlight that in your recursive resolvers that you should be practicing, right? So there are different practices you can see. Like this, for every category, you will see different practices that you can implement. If you can implement all these things, that means you are running a very secure DNS operational environment, right? You can do a self-assessment. If you go to here and do click on self-assessment, you can do yourself. You can be anonymous, right? You can be anonymous and you can do a self-assessment. Say, for example, it says, okay, DNS operator self-assessment covers two aspects: your core DNS operational practices, your core system security. So if you want, organization is optional. You don't have to give that. And then it will ask questions. Okay, it's asking why you are taking this self-assessment. Maybe you can say you want to join kindness, for example. And then it will ask questions. Okay, the part one is core DNS operational practices, right? So which components of the DNS do you run? So if you are a recursive, so if you are ISP or if you are a mobile operator, you might be running recursive servers. Or sometimes some ISPs, you may be doing both because you could be managing second level domains for your customers as well, right? whether you are only running authoritative servers or whether you are running recursive servers, or you are running both authoritative and recursive, or you are managing, your DNS is managed by a third party, another company, right? So whatever applicable, say, I will just click one of these. And then what type of recursive resolvers do you run? Remember, I was explaining about private recursive resolvers and different types of resolvers like this. Yeah, so you can actually keep on, and then it would ask you what practices are you practicing, and so on. I'm not going to go through all this, but you can try this out. You can do some self-assessment, right? As I said here, depending on your name category, name server category, and then see whether what type of best practices you are applying in your environment. And if you are not applying those practices, it will give you an opportunity to practice those or apply those. In case if you have some difficulty, feel free to write to us, right? You can write to us and ask questions. We can help you out. And also you can join Kindness. Once you are, done with this, you can probably, if you want, you can join Kindness. If you want to join Kindness, then it asks you, this is all, by the way, these are all free services, right? You don't have to pay anything or anything like that. You can join, you can write to us, fill this and submit it, and then we will correspond with you to help you to deploy those practices in your environment so that we can help you to run a secure and a safe DNS operational environment, right? So that's the whole idea about this Kindness. I think I just want to quickly mention you before we actually finish our session for today. I believe now our time is up. So I hope this session has been useful to you. In case if you want to be in, I will send you this slide deck as well. I'll send it to Kind, and then and she can pass it to you as well. If you have any questions, do keep in touch, and hopefully we will have some. If you think that you want to have some more training sessions on DNS, or more hands-on type, if there are operators, I mean the people who are really doing DNS administration who need some hands-on type training, we can help you out as well. Important thing is keep in touch, and we are quite happy to help you. I think at this stage I will stop, and then let Kind take over and continue.
Thank you, Mr. Champika. Thank you so much. And any question? Any question? There's no question. Thank you, Mr. Champika.
Yeah, thank you very much, and hope you had some information out of this session, and then let us keep in touch.
Okay, sure.
Thank you. Bye-bye.